Alright, so let's look at dividing complex numbers. And the question here is, how does the multiplying complex numbers help you divide complex numbers? And so when you're dividing complex numbers, the whole point is this: to get the imaginary numbers out of the denominator. You want to get the imaginary number out of the denominator. And it's a lot like rationalizing the denominator when we do that to get rid of the radical, but we're trying to get rid of the imaginary number. So if you remember on the last lesson where we multiplied by a complex conjugate, and that was just the thing that was exactly like the complex number, except the imaginary part, you changed the sign, and that made the imaginary part go away. And so what we do here is kind of like rationalizing the denominator. And remember, when we do that, you have to multiply the numerator and the denominator by whatever you're trying to, by whatever you're trying to, or by whatever you need to make that denominator not have that radical in it. But now we're going to multiply by what we need to not make that denominator have the imaginary part in it. So you're going to multiply the numerator and the denominator by your complex conjugate. I'm sorry, I didn't leave room in there to write those steps, and so I'm just squeezing them in. So the point is to get the imaginary out of the denominator, and you do that by multiplying the numerator and the denominator by your complex conjugate. So it's just as simple as this. If I've got 4 over 1 minus 2i, I'm going to multiply by 1 plus 2i in my numerator and my denominator. So that means I've got to do 4 times this, so I'm going to distribute the 4. It's going to give me 4 plus 8i. And then on the bottom, and we've done this, a binomial times a binomial, you do your distributive property twice. 1 times 1. That's going to give me 2i. When I do this times this, 2i minus 2i is going to be 0, so it's gone. And then you've got negative 2i times a positive 2i, and that gives me a negative 4i squared. So then you've got to remember your rule that when you multiply by a complex conjugate and you get that I squared, that I squared is negative 1, and it just changes the sign on the number that it's attached to. Remember that rule. I squared equals negative 1. So I've got negative 4 times I squared, which is the same thing as negative 4 times negative 1. So just mark out the I squared and change the sign. And now we can simplify, finish it out. I've got 4 plus 8i over 1 plus 4, which is 5. You want to check these numbers and see if they all have anything in common. If they do, you may be able to just simplify out by a factor of, like, maybe they all have 2 in common, or maybe they all have a 4 in common. So you're just going to check and see if that's the case. Okay, let's do this one. My complex conjugate is going to be the opposite of my denominator, so it's going to be 3 minus 8i. So you're going to use your distributive property on the top. 9 times 3 is 27. 9 times negative 8i gives me negative 72i. Over, and this is the easy part, like really this is the easy part. 3 times 3 is 9. This negative 24i and positive 24i is going to be 0. And then you multiply 8i times negative 8i and you get negative 64i squared. So then apply that I squared property. I squared is negative 1, so it changes that to a positive. Now, in my numerator, 27 minus 72i, and 9 plus 64 gives me 73. And that's my answer. And then for the third one, the complex conjugate of this one is 7 plus 7i. And 7 plus 7i. So in my numerator, I'm going to distribute the 6i. Notice that's got an I on it now. So that's going to give me 42i right here. And this is going to give me a positive 42i squared. Hang on to that for a second. In the bottom, 7 times 7 gives me 49. This 49i and negative 49i is 0. So negative 7i times 7i gives me a negative 49i squared. I got an I squared in the numerator, and I got an I squared in the denominator. I squared is going to make that a negative 42. I squared is going to make that a positive 49. Now to put it in standard form, in my numerator, I need negative 42 plus 42i, and 49 plus 49 is going to give me 98. Now I'm looking at those numbers, and I see that they're all even, so I know they're at least all divisible by 2. So if I take a 2 out of here, a 2 out of here, and a 2 out of here, I'm going to get negative 21 minus 21i over 49. I'm looking again, and I see that they're all divisible by 7, so I'm going to simplify again. 7 goes into negative 21 negative 3 times. 7 goes into negative 21i negative 3i times. And 7 goes into 49 7 times. Now I'm finished. You could have simplified everything out by 14 in the beginning if you had seen that, but you may not get it all the first time, and that's fine if you don't. So I'm going to pause the video. I want you to do the 3 at the bottom and check them, and then we're going to do the next set, okay? So I'm going to pause it now. You press pause too, and then you're going to check your answers. Alright, check your answers. The only thing that I want to say here, if this is a mistake that you made, and I hope that you did not, is that negative I squared is like a negative 1. So if I squared is negative 1, then I have a negative 1, which makes me have a positive 1. So anytime you end up with a minus I squared, you're just going to change that to a plus 1. Because that ends up being, here's the side work for that. That's 4 minus negative 1, and that just gives me the 4 plus 1. And on this one, my conjugate, the only thing that changes is the sign on the imaginary part. That negative 1 did not change. Alright, let's look at the other side. The other side's the same thing, except I have a binomial in the numerator, and so it's just a little more work. So we're going to multiply by the complex conjugate of the denominator, 2 minus 3i over 2 minus 3i. So it's distributive property here and here. And then here and here. And then in the bottom, you can just do your shortcut. This times this, because that negative 6x and positive 6, negative 6i and positive 6i are going to give me 0. The only difference here is that I have another I squared here, so that's going to make that a negative 12. That I squared is going to make that a positive 9, and now you combine my terms. So I have 2 minus 12 gives me negative 10. Negative 3i minus 8i gives me a negative 11i, and 4 plus 9 is 13. Those numbers don't have any common factors. We don't have to worry about simplifying anything else. Number 2, I'm going to multiply by the complex conjugate of my denominator, which is 6 plus 3i. And you do the same thing. Distributive property here. Distributive property here. in my denominator, y'all, you got to do is multiply the first two together and the last two together. Because the 18i and the negative 18i are going to give me 0. So now I've got some I squareds that are going to change some signs for me, and I can combine like terms. 18 minus 24 is going to give me a negative 6, and negative 9i plus a negative 48i, or negative 9i minus 48i, is going to give me a negative 57i, and 6 plus 9 gives me 15. These numbers are all divisible by a factor of 3. Yeah, so 3 will go into negative 6 negative 2 times. 3 will go into negative 57. Let me just do it so I don't get it wrong. Negative 19 times. And 3 will go into 15 5 times. And that's my answer. Looking at number 3, same thing. Multiply by the complex conjugate. You're only going to change the sign on the imaginary part. And we're going to do our distributive property here. Gives me negative 10 plus 20i. And our distributive property here gives me a positive 2i and a negative 4i squared. In the denominator, that's going to give me a positive 4. And then I multiply here and get a negative 16i squared. Apply that I squared rule that changes your sign because I squared is negative 1. And I've got negative 10 plus 4, which gives me negative 6. 20i plus 2i gives me a 22i. And 4 plus 16 gives me 20. They're all even, so they're at least all divisible by 2. So if I factor a 2 out of everything, that gives me negative 3 plus 11i over 10. I'm going to pause the video again. You're going to pause the video on your end, do the next 3, and then you're going to check them. Okay, so check them. You can pause the video so that you can look at my work. I did my conjugate, 4 minus 3i, did my distributive property twice, the I squared changed that sign, the I squared changed that sign, and this is what I got. This one, you might have thought maybe you did something wrong because you didn't have any imaginary stuff anywhere, but when you did your multiplying here and you got negative 1 plus I, and then negative I minus I squared, well, the minus I squared makes that a plus 1, sorry, that's a plus I squared, and that plus I squared makes that plus a negative 1, so it's minus 1, and negative 1 and negative 1 is negative 2, I minus I is 0, that part's gone. And then in the bottom, you know all you're going to have is this plus whatever you have here, so 1 plus 1 is 2, and my answer is negative 1. On number 3, same thing, complex conjugate, multiply the distributive property, the I squareds change the signs, and I got 10 plus 14 over 30, 14i over 37.